Hello, welcome to 714 Geometry. So your book is page 447. Our learning goals of the day, we're going to dilate geometric figures to show enlargements, reductions, and congruent figures. We're going to identify the scale factors of dilations and produce dilations at a given scale factor. And we're going to use similarity transformations to determine whether two figures are similar. And we got some words here. We did an activity just before a class where we did a dilation, and we're going to talk more about that and also similar figures and similar triangles. So you guys have all done this. You have your phone, you zoom in, you zoom out by making your fingers go bigger and smaller. So if you wanted to estimate how big something got, so here we have estimate the scale factor to produce when you pinch the screen to create this one. So the pre-image, that's what I start with. So if I started big, I made it smaller, that's gonna get smaller. So, and if I look at the scale factor, this looks like it was twice as big as this. So the scale factor for A would be 1/2. And since I already identified that this is 2 times as big as this by estimate, if I started with the small one and went to the big one, I would have doubled my length, so it would have been 2 times. So a rule to know, it's going to be helpful, is when it's greater than 0 and less than 1, this figure's going to get smaller. And when it's greater than 1, it'll get larger. If it is 1, it will stay the same. So this is now a non-rigid transformation. Before, when we did rotations, translations, and reflections, they were rigid, where we weren't doing dilations, and it stayed the same. So if I do a dilation, it stays the same. It's not really doing much. So dilation produces a similar figure. Similar figures are geometric figures where all parts of corresponding angles are congruent and lengths are proportional. Now, before we learned about congruent figures, congruent figures have corresponding angles are congruent, but corresponding sides are congruent still. So the difference between congruent figures and similar figures is the lengths are proportional, but all the angles still have to be the same. So if I'm going to make a dilation, I can get my lines starting at my center of dilation. I'm going to go through, and I'll just do this twice, but I should do it at all the different points. I could do it for here to here, here to here, here to here, and if it goes through the corresponding point, it would be the same. It would be an actual dilation. So here I'm going through the little crux elbow part of E, and it goes through X. Here I go through the leftmost tip of E, it goes to the leftmost tip of X. Here I go through the little elbow part at E right here, and it goes to the same thing, X. So these are going to be dilations. So I'm supposed to use a metric ruler, and this is on the computer. You guys have a different picture, same picture, different size, so my numbers won't be the same. But I'm going to use a metric ruler, and what I know about dilations to demonstrate that E is a similar figure to X. So I can put this here. Now, the distance from, in my picture, 0 to the tip of E is 5. And then it goes, oh no, actually it's 4.9. And then it goes from 0 to 10x is 9.8. So I'm going to put some numbers down here. The first one was 4.9 to 9.8. That was this line. Then I can move my ruler, I'm gonna rotate it, I can put it here, and here it goes from 5 to 10. So the same thing, the smaller distance is 5, the bigger distance is 10. Now you should be knowing this is 1/2, but also if I double this, I get the same number. So they're both 1/2. So since they're both the same proportion, the figures would be similar. Now, would I technically need to test every part? Yeah, I could have a wonky star that goes like this, but then I would be like, well, that's obviously different. So for a shape that looks the same, I don't have to test every one. But if I had this, I'd have to test here to here to here, and it would definitely not work. It wouldn't be a dilation because I'm connecting here to here, and it's a different line. This line doesn't go through the same corresponding part. So for A, what do we know? We know that they are the same because the lengths of corresponding sides are proportional, which I did up here. What do you know about the angles? Well, since I showed that the figures are the same, I know that the angles now are going to be congruent for B. So here, angles are congruent. And here, sides are proportional. Well, what scale factor will produce the same thing? So if I'm going from here to here, it's not getting, it's getting bigger. So if I'm going from X to E, um, wait, hold on. So back up. Use the E is, okay. So it didn't say which was the pre-image, which was the post-image. If X was the pre-image, then it would be a 1/2 scale factor. If E is the pre-image, then X would be a 2 scale factor. What scale factor would make congruent figures? That would be a scale factor of 1, and I already talked about that on a previous slide. Part of your Delta Math homework is going to be doing a series of transformations where you have some that are rigid and some that are reflections, translations, and rotations. So this figure A is where I'm starting. How would I get to B? Well, I want to start off at least by having a reflection. So I'm going to reflect over the line because these are mirrored images of one another. And then if I look at it, and I can just do quick, this line is that length, move it here, and oh, they're not the same length. So what would I do? I would need to do a reflection then a dilation with scale factor being less than 1. That's going to make it smaller. So here's another one for you guys to try. Pause the video, try it, and then I'll be back waiting for you when you're done. Okay, welcome back. So it looks like I have this picture, and I'm going to make a rectangle here. Make the sides black. Oh, I made the inside black. Close enough. So it is obviously rotated. So I'm going to rotate it 90 degrees. And if I rotate it 90 degrees clockwise or counterclockwise, it's going to be the same. So I'll just rotate 90 degrees. Then if I look at it next to this one, well, obviously is smaller, so it has to get bigger. So my answer for this one would be I'm going to rotate 90 degrees. and then dilation with scale factor greater than 1. Another one, use the definition of similarity in terms of transformations to determine whether each of these figures are similar. So these are similar triangles, same sort of definition as similar figures, where angles are all going to be congruent, but the sides will be proportional. So how am I going to be able to do this? I'm going to get my ruler. Oop, gotta be. I can put it right here. So I'm going to measure the distance of X to U, or W to U, and then from W to Y. So the distance of WU is going to be 3.1. And then W to Y is 5.6. And then I'm going to rotate this ruler a little. And the distance from W to T is 4.4. And then the distance from W to X is 8. So these aren't very nice numbers. I'm sure you might have gotten better numbers on yours, so just measure yours. But if I put these in the calculator, 3.1 divided by 5.7, 5.6, I get this equals 0.55. And then if I put this in and get 4.4 divided by 8, I get exactly 0.55. So it is going to be proportional. So therefore, these triangles are similar. So this is where you guys are going to do 2 problems out of your book. So do them in your book on page 458, problems 5 and 6. You're going to do those, then you're going to sign up, and when there's 3 kids or 4 kids that have finished it, you're going to have a talk with me, and I'm going to make sure that you guys fully understand it.